In example 10, if 6 joules of work is needed to stretch a spring from 10 centimeters to 12 centimeters, and add another 10 joules is needed to stretch it from 12 centimeters to 14 centimeters, what is the natural length of the spring? Well, since we're looking for the natural length of the spring, we need to define it. By defining it in step 1, we're going to let L be the natural length of the spring. In step 2, we have our function. We know that 6 joules of work is needed to stretch the spring from 10 centimeters to 12 centimeters. So we know that this integral is going to equal 6 joules. The function is kx because we're going to need to solve for k. But now our upper and lower limits, okay, we have our lower limit as 0.10 minus L, since we don't know what the natural length of the spring is. And our upper limit is 0.12 minus L. So now when we take the antiderivative of this function, we're going to get 1/2 kx squared, going from a lower limit of 0.10 minus L, 0.12 minus L. So therefore, we're going to end up with 1/2 k times 0.12 minus L squared minus 0.10 minus L squared. And that's going to equal 6. Now, another 10 joules is needed to stretch it from 12 centimeters to 14 centimeters. So we're going to have now 10, which is going to equal 0.12 minus L, 0.14 minus L, kx dx. Now keep in mind that our 12 centimeters, 10 centimeters, and 14 centimeters are converted to meters. So that's going to equal 1/2 kx squared with a lower limit of 0.12 minus L, an upper limit of 0.14 minus L, which is going to equal 1/2 k times 0.14 minus L squared minus 0.12 minus L squared. So now what we're going to do is we're going to end up having two equations. So we're going to have the first equation and the second equation. Okay, so what we can do with the first equation, we know that we have 1/2 k, so we can multiply both sides by 2, so we get 12, which is equal to k times 0.0044 minus 0.04 L by squaring these two and then subtracting and combining like terms. Same thing with the second equation here. We're going to multiply both sides by 2, multiply this out, and then combine like terms, so we get 20, which is equal to k times 0.0052 minus 0.04 L. And what happens is now we end up getting two equations so that we're able to solve for k. So we're going to have to use the addition by elimination. So we have our first equation here, our second equation is here, and so in order to eliminate the value of KL, we're going to multiply the first one by -1, and then we're going to keep this one the same. And so therefore we can then allow us to eliminate that, and we end up getting 0.0008 k, which is equal to 8. And now in step 4, we need to solve for 8 by dividing both sides by 0.008. So now we know that k is going to equal 1,000. So now we're going to plug 1,000 now back into that equation to solve for L. So you can use either 1, 1, or 2 to solve for L. By plugging in 1,000 in for k, we end up getting 20, which is equal to 52 minus 400 L. Subtract 52 to both sides, divide by -400. 32 divided by 400 gives you 0.08 meters. And then converting it to centimeters by moving the decimal place to the right twice tells you that the length is 8 centimeters.